Alright, welcome back. This video is all on chapter 4 on your text. We're going to be going over starting the arc, what actually happens when you strike an arc, how to strike an arc, things like that. We're going to go over some of the flux bases of your electrodes. So, very first thing, when you actually strike an arc and you start welding, what happens? So here's my electrode. I strike an arc. Here's the core of my electrode. This is the flux coating of the electrode. When I strike an arc, this flux starts to melt and creates a cone. Here's the metal droplets from my metal core of my electrode. So what actually happens when you strike an arc? Your flux starts to melt and it forms that cone over your weld, protecting that weld from atmospheric gases. It's doing the exact same thing as a shielding gas. That's what your flux does. So like your shielding gas, it displaces atmospheric gases so none of them can make contact with the weld. So when you're actually melting that flux, it reacts with these gases, creates a cone that helps protect your weld. Now, to actually start an arc with stick welding, it's a lot of practice. There's many different ways. So if this is my base metal, I'm going to strike an arc. A lot of guys will tap it a little bit. They'll scratch start it, whatever you may do. It's a practice thing. The only thing that you can really get good at starting an arc is just get in there practicing. You might want to tap it or scratch it on the metal. It's just a practice thing. It's time under the hood and it'll get you better and better. One thing I do know, a lot of times when they make the electrodes, the flux coating may cover that center core. So this is what an electrode actually looks like, just so you understand what I'm talking about. You have your center core, that's your filler metal, and it's covered with flux on the outside. So when they make these electrodes, a lot of times that flux drips over the end of that core, and it's not. A lot of the welders, before they strike an arc, they'll take that electrode and scratch it on the base metal, not while it's in the electrode holder. So just grab that electrode, scratch it, put it in the electrode holder. What it actually does is knock the flux off, gives you a good surface to actually start your arc. So when you start welding, like I said, starting that arc, you can tap the electrode down, scratch it, whatever fits your style. Everybody's different, but the main thing is it's a practice thing. You got to practice it, get it down, and we'll go from there. So when you actually get your arc started, what actually happens is here's my electrode, here's my base metal. This distance from here to there is my arc length. The distance that my electrode is off my base metal is determining my arc length. Usually in stick welding, you're looking at a fairly short arc length. I mean, you're looking at probably an 1/8 inch to 3/16 of an inch off that base metal, sometimes a 1/16 of an inch. You get too close, you actually start digging into the base metal. You get too far, you actually get a lot of spatter. So this distance here, for example, here's my little droplets of metal being thrown to my base metal. If I increase that arc length, you have more area for that metal to spray out. So you get a lot of spatter with a larger arc length. You'll notice too when you start welding your vertical ups or your overheads, the shorter the arc length, the more control you have over that weld puddle. Very important. Very, very important is controlling that arc length. Like I said, this is just practice. Time under the hood. Starting that arc, maintaining that arc, having a constant arc length, it's just practice. Because in stick welding, you manually got to feed that electrode in. All it is practice under the hood. Now when you actually get out there and you start welding, you get your arc length under control. Setting your current is also big, your current settings. When you got your current set too low, what happens? A lot of times your electrode will actually stick to your base metal. So as you're welding, you got your electrode comes down. If your current is set too low, you'll find yourself that you're sticking that electrode a lot. That's one key, that your current is set too low. Another key is that you're not getting complete fusion into your base metal. That's a key, that your current is set too low. Typically in the flat position, you can weld a little bit more current than you can vertical ups. Vertical ups, you want to set that current about as low as you can. That helps you maintain that weld puddle, and it also keeps your weld from drooping. So adjusting your current is huge with stick welding, and it's a constant current. So for example, you had it set at 120 amps, it's going to stay at 120 amps. So like I said, a lot of this is just practice under the hood. You'll notice it's too low, like I said, it's going to stick a lot. You're not going to have complete fusion. If you're too high, if your current is set too high, you'll see that you'll have a lot of spatter. You'll have undercut, things like that. And you'll notice when you start welding your vertical up, if it's set too high, your metal is just going to fall right down. You'll have that big drooping weld, and we're not looking for that. So starting your arc, adjusting your settings, that's basically just practice under the hood. Everybody welds a little bit different, things like that. But once you get all that kind of adjusted, you get your current set to where you want, you got a good constant arc length. Typically in stick welding, the angles that we weld is almost the same. So for example, here's my electrode going down. We're usually about a 15 to 20 degrees. We're welding this way. We're going to be using a backhand progression. So our electrode is pointing in the opposite direction that we're traveling. Typically that's what we use. A rule of thumb that's used in industry, anything that creates slag, you drag. So we're creating slag with stick welding because our flux is solidifying over the weld. We want to drag it. The main reason being is because you don't want that slag deposit. So if we're going in a forehand progression, that slags want to fall in front of that weld puddle, and you actually create slag inclusions, which is what we don't want. So anything like we use that creates slag, like even flux core welding, we're going to be doing the backhand progression. Arc lengths, like I said, maintain that short arc length. Get your electrode, put it down about 15-20 degrees back, and we're going to drag it. Drag or backhand progression, they call it. Angles are really critical. For example, let's say if we're doing a T-joint, we're going to do it from the side view. Typically you're going to be close to about a 45-degree angle. It's a little off, so let's go in like this. And you're going to run it 15-20 degrees angle backwards in a backward progression. The thing is when you actually chip that slag off and you're looking at that weld for your angle into your T-joints or whatever it may be, we want half the weld to go up and the other half to go out. You want that weld evenly distributed on your vertical piece and your horizontal piece. That's the main thing. If it is not, that means you're going to have to adjust this angle in either direction. So keep that in mind. Stick welding, you can do circles. They call that weld pool manipulation. There's a stringer bead. A stringer bead is just basically going just straight. You're not doing any circles. You're not doing zigzags. You're not doing half moons. It's just basically a straight drag. Weld pool manipulation, that's what they call a weave bead. You can either weave it, do circles, you're manipulating that weld pool. And that is allowed in stick welding. Now, a lot of the times if you need a smaller weld, a stringer bead might work well. If you need a bigger weld, or if you've got to cover your gap, you'll actually do a weave bead or some sort of weld pool manipulation. That is allowed stick welding. When you get into doing your bend tests, for example, you're filling in that V groove. Your V groove looks like this. You put your first pass in, might be a stringer bead, then you might actually weave this bead or weave two beads over the top, however you do it. So a stringer bead's got a certain application, a weave bead's got a certain application. It's up to you the welder. Like I said, it's primarily practice under the hood. But keep in mind, stringer beads is straight. Weave bead, there's actually weld pool manipulation. Now in this class here, we're going to be using two different types of electrodes. Primarily we're going to be using a 6010. And a 6010 is what they call a cellulose base flux. 6010, 6011, we're going to be using 6010, but a cellulose base. I think I have that spelled correctly. Cellulose base is basically, doesn't have a lot of flux, very thin coat of flux on the actually rod itself. Not a very smooth arc, they're kind of harder to weld with, but you get better fusion. And it's harder to control your arc. 6010s, like I said, they're primarily used for like root passes. So when you get into industry and you're doing a lot of stick welding, typically a 6010 is used for a root pass. You get really good fusion. There's not a lot of flux. Also, they're really good for welding out of position. Why do you think they'd be good for welding out of position? Because we have less flux. It means we can control our arc better as we're welding vertical up. We have less stuff to control. So 6010 cellulose based flux, you can see a huge difference when you switch from 6010 to 7018. It's not a very fluid puddle. It cools a lot faster. That's probably one of the main reasons we weld out of position with them. And you do your root passes with them. They cool fast. So keep that in mind. They also have what they call a rotobase flux. These are like your 6012s and 6013. We do have a little bit of 6013 out there. Typically 6013. You'll see that there's a little bit more flux coating over that rod. And what that does, it gives you a little bit better arc control. The puddle's a little bit more fluid. 6013 is basically what they call an all-purpose rod. It can be welded at any current, any position. We'll get into like the 6013, 6010, 7018, what these numbers mean in chapter 28. We'll go through we'll break it down so you understand where to use these electrodes and where not to use them. Primarily 7018, that's going to be our primary rod that we were going to be using. That is what they call a mineral-based flux. What does that mean? That means this is a very fluid welding rod. You can control the puddle, it's a little more forgiving. It's not like your 6010 where it cools very fast. Look at the amount of flux over that rod, for example. Let's take a 6010. Looks like that. 7018 looks like that. So the amount of flux covering that center core of your electrode is a lot more for a 7018 compared to this is 6010, 7018. It cools a little bit slower. The amount of flux is a lot more flux covering that weld. These are mineral-based electrodes. Very fluid, very smooth arc, very good, easier to weld with. Let's just take a look at something here. We'll show you why 6010 is different than a 7018. Here's a T-joint. Here's my weld, and then I have this very thin flux coating over my weld. This would be like a 6010. Now that weld's going to cool a lot faster compared to a 7018. So here's my T-joint. I put a weld here, I'm going to have a lot more flux covering that weld. Because I have more flux on my rod. Now when you think about slag covering a weld, it's like a blanket. It's like a blanket that covers that weld. We have a very thin blanket with our 6010, a very heavy blanket for 7018. So you can see that this one here is going to cool a lot faster than a 7018. 7018 is going to cool a little slower because we got more slag covering than a 6010. But you have better electrical characteristics, smoother weld with the 7018. Not near the amount of fusion that we're going to have with the 6010. You're going to get a lot more fusion with your 6010 compared to your 7018. So when you're out in the lab, primarily our rod's going to be a 7018. We're going to do a couple applications where we use a 6010 root pass, 7018 overlay. Get familiar with them both. These are probably the most common two electrodes used in industry, a 6010 and a 7018. To get the weld with them, it's just practice. Time under the hood. Use both electrodes. Spend a lot of time starting your arc, running beads with both, because you're going to be using them both if you get into the stick welding profession, a pipe fitter or whatever it may be, a maintenance worker. So basically when it comes down to it, get in there, play with them. You'll notice that the current settings are going to be a little bit different. You're going to have a lower current. For a 6010, you're going to probably be running around 90 to 100 amps compared to your 7018, you're probably going to be around 115 to 125 amps. And that's all because we have less flux here, we have less things we have to melt compared to our 7018 electrode. Hopefully this was helpful. Read Chapter 4, go through it. Chapter 4 also gets into some practice applications. Don't worry so much about the practice applications. Because when you get out in the lab, you're going to have the prints that we want you to do and want you to practice with. But spend a lot of time under the hood playing with both these electrodes if you're looking into the stick welding profession. Thank you.